So we are ready for the first technical session of this workshop. As it has already been told, the prime concept behind this workshop. So you came from different places, and as per the objective, you will be made aware of the different analytical techniques, the instrumentation part, the application part, as well as the hands-on training on that particular instrument. So in the next 7 days, we will try our best to expose you to the different instruments that we have here at Guru Nanak Dev University in our central facility building. So to start with, the first technique that we would like to cover is the mass spectrometry. For this mass spectrometry, we have requested Geol India Private Limited to deliver 2 talks on the basics of the instrumentation and the application part. And later on, as I told in the afternoon session, we will take you to the mass spectrometer to show you how it works and what you can do with the instrument. So we have with us Dr. Deepak from Geol India, who did his PhD from the Institute of Chemical Engineering, Mumbai, and has expertise in proteomics as well as in the use of mass spectrometer for different applications, covering metabolites, small molecules, proteins, and a number of other applications you can interact with when he will deliver his talk. And similarly, Dr. Rahul Grover is also associated with Geol India, and both of them, being the representatives of Geol, they will like to show you the different components. I would specifically mention that these people, they really know what is there inside the instrument. That as a academician, I cannot tell. They know each and every component, how it works, and how you can use the instrument, not only for recording the mass spectrometer, not only for recording the mass spectra, but several other applications that we never have thought of. They will tell us that you can use the instrument for this and this purpose. So
taking care of mass producing business for the Indian market, and apart from this, Indian market, and apart from this, we have a division for the financial institute. We will deal with NMR, SC, the take care of states from north, and that's part of this. So I'll start with the MS technique. We'll go with the basics, then Dr. Deepak will take care of the application part. It's about the MS techniques. And as the context of presentation is, it started the complete profile of key introduction how we use, followed by the basics of mass spectrometer. There are some key components involved in mass spec, because of which complicated techniques are available. Then already have mass spectrometer solutions available to you. So to begin with this complete profile, we founded this company in 1949. GEO stands for Japan Electron Optics Laboratory Company Limited. We make the analytical. We are glad to inform you that we are listed in top 10 business worldwide for manufacturing analytical. So we have 2 divisions. One is analytical instruments. Where we have LCMS, GCMS, for which we are talking about today. Apart from this, we have the PEM, SEM, NMR, ESR, and XRR. And then we're talking about the product too. So we are supplying to IIT Delhi SATU project. We are supplying high resolution which is meant for the material science. Then we have the industrial equipment wherein we have this EBS nowadays very popular technique. So we have this geo network spread all over the world. We are into businesses and innovation and we qualify. So this is about Jewel India. I'm being from head office from Delhi. So Jewel India was established in 2011 as an independent subsidiary company of Jewel India in Japan. We have regional offices all over the country to take care of the various aspects of the user part, application areas, and everything. For the southern part, we have 3 offices now: Bangalore, Hyderabad, and Chennai. The eastern region we are taking from Kolkata, western region Mumbai, and Delhi, which is based in I guess now in we have around 450 instruments of all the varieties, sample PEs, mass specs, and all. We have dedicated service and application team for each product line, which is actually a key requirement for these kind of sophisticated tools. Then we have a dedicated spare parts and investment team. So to begin with, I believe most of the students are using the mass spectrometry technique in daily routine. So this is basically an analytical technique which involves the study of gas-phase violet molecules, and our aim is to get the molecular determination, structure characterization, gas and reactivity study, and we can do the qualitative and quantitative analysis of components and mixture. But the thing is, there are many complementary techniques are available. The reason is there are advantages and certain limitations of the components of a mass spec, which I'll be covering with the slides. So this is how you can see the basic component in any of the mass spec. You might have heard about the GCMS, LCMS, LC-top, or the GC-top. So the basic component remains same. There will be a sample inlet system which will be used to introduce the samples from the ambient room pressure to the ionization source. We have an ion source which will convert your sample molecules to the ions. Finally, there will be ion transfer system. Then there's a mass analyzer which will separate the ions according to their masses, followed by the detector which will detect the ions and amplify the signal, and finally the recorder where you generally see the spectra. So this is the basic component which makes a spectrometer. By varying the sample inlet, ion source, mass analyzer, there are a variety of mass specs available now. So to begin with the sample inlets, I believe most of the students must be aware about the chromatographic system, called the liquid chromatograph or gas chromatograph. If your sample is volatile in nature, we use the gas chromatograph. If your sample is soluble, then we use the liquid chromatograph technique to we use the chromatographic technique to separate the analyte in a complex mixture. The most important part in case of mass spec, as far as Joule is concerned, that we have the direct inlet rules. You must enter some of the samples which are not soluble or which are not volatile in nature, and how to do the analysis till you go to mass spectrometer. So we introduce direct probes by which you can directly inject your samples into the mass spec. You can get the spectra out of it. There are 3 types of probes are available, which is the direct insertion probe, direct exposure probe, and a field desorption probe. I will not be discussing in detail about LC and GC. I believe people must be aware about that. So, to give a glance about the direct probes, so the first one is direct exposure probe. You can see there is a platinum filament, which is suitable for the high volume point samples, which is thermal lapping compounds as well. This is compatible with EICI. These are the ionization sources. I'll be sharing this diagram with you on the slide. So the sample dissolved or dispersed in a solvent is applied to the filament directly, when we directly inject the sample inside the mass spec. We can bypass the LC. The other probe which is available with us is the DIP, which is direct insertion probe. We have a glass sample tube which can be filled by a solid sample, which is not soluble. So this solid sample which can be introduced in the glass tube directly. It is again suitable for the high volume point or insoluble components. Then again it is compatible with the EICI. EICI basically the ionization sources, which I said will be covering the other slides. Then we have a field desorption probe, what is the FDP. This is majorly meant for the high molecular weight compounds. And we use the special technology for GC-top system, which is compatible with that. So these are the various ionization sources available. After sample inlet, the key component in mass spec is the ionization sources. The first 4, which is electron ionization, chemical ionization, FIFD, and FAB. These are the ionization sources which are compatible with the GCM system.
The probe works with all the organization groups.
EI and CAC.
Only EI, CAC.
Yes. And for FIFD, we also have a coalition top level systems built for the complex samples of the petrochemical business. And then they are using that. Then ESI, APCI is a very common type of ionization source which people use with the LCM system. We have again a specialized technology specialist tool called multi-top and this is recently installed switching CCM Hyderabad. They are ready working on proteomics. So they got a machine from us. Then we have last but not the least DART, which is direct analysis in real time. This is the tool which actually meant for majorly for the forensic people where you have to do the analysis of the sample in its native form. You are not supposed to change the form of the sample. You can directly get into the analysis. Sorry, Mark. In Northern India, we have discussions are going on. In CCM, Hyderabad, we have sort of discussions. There are two companies, Geo and Cooper. So Cooper has some CCM Hyderabad only. Because actually, I will just take 1 minute. So mass spectrometry we are not focusing earlier. So we are a very small player because of mass spectrometry. Our approach is very clear. We are supplying only, we are ready for specific application needs. So multi-top, again, this is only made for the proteomics people. We come across the new technology now, we can use the multi-top for a small molecules as well. But the people will be sharing some of those factors to elaborate a bit. DART, as I said, is for the forensic people. Suppose any drug or anything you can directly do the analysis, you are not supposed to change it from. So DART is meant for that. These are the common analysis sources which is used in the GCM system. So earlier we don't have the single quad system or triple quad system. Now we come across with that also. So this is the reason now because we have support system available. So now we started promoting this product. I will show that PDF will be open for this. So this is going to give again a glance at how to select the right ionization source. So if the sample, if your sample is volatile in nature and mass range is up to 1000, then EI or CI ionization source is more than sufficient ionization. It is compared to the GCM system. Then the next we are talking about the DART MS. This is the range that DART MS can do, and up to 1000 molecular weight compound we can ionize that. Apart from this, we have a FDFI, which is compatible with the GCM top system. Most of the petrochemical people are using that. Wherein if the molecular weight is up to 10,000, if the molecular weight is up to 10,000, we are able to ionize the set of molecules. Then ESI source, which is you can see the most common spectrum, most common type of mass spectrometer which you see in the institutions, the LCMs. The main reason is you can see the range. So we can ionize the molecule which has a molecular weight of close to 100,000. So multi, as I mentioned, it is meant for the proteomics people wherein we have to image or you have to get spectrum of the entire protein. So people have the samples wherein your mass is specified at 1000 times and multi can ionize that. So I have a PDF to elaborate. I'm not sure whether it's going to open or not. So people can maybe I can cover this later. So we have a schematic diagram of how this CI works, CI works. So tell you a bit, EI is called as electron ionization. So there is a filament. We apply bicycle 70 eV. This reason is called as a hard ionization technique. And finally, it interacts with the gas molecule. And you get the spectra output. It gives you the structural information. Now it's good for the known settings. The thing is, suppose you have an unknown setting. In that case, there was not what you wanted to be. So in that case, we go with the CI, which is a soft energy technique. Wherein we apply 8 to 10 eV to this and we get a molecular identity. I'm not able to open that, otherwise I have a spectra. I can show you what we compare it to. But to the data spectra of unknown center with the EI, let us CI compare that to get results. We have a specialized software called DST analysis, which we recently supplied at Shell R&D Bangalore. They are working. I'm sorry, it don't work. So the next section after that is the analyzer time. So there are different types of analyzers available. To begin with the single quad MS. Then we have a triple quad MS, the time of flight mass spec, ion trap, and a magnetic sector mass spectrometer. We generally play around with all the parameters to improve the resolution and sensitivity. We have recently announced a GC top average will be very high sensitivity, which I'll be talking about for this slide. We have recently launched GC triple Q also, so the success rate is built for the pesticide residual analysis specifically. This is how single quad MS looks like. As a quad says, there are 4 rods. You can see that generally as a user, what you do, you your sample in the GCMS, you select the ion you are interested in, or the mass you are interested in, and then you get your spectra out of that. Internally, we apply biasing to this, and then it will be detected by the detector. Every OEM has their own USPs. In our case, we use a pre-filter to keep it clean for a longer duration. We are using
I have just joined.
Analyzers so that we can cater to the higher dynamic range. Then a very important aspect in case of a single quad MS is about the EI source. It has to be changed frequently. It depends upon the number of samples you are analyzing. In our case, don't use required for that. The second one, again, triple quad analyzer. The main difference is where you can see only one Q1 for the Q1. In this case, we have Q1, Q2, Q3. Q1 is the same. There are 4 rods. Where you can select your ion. We have a CID wherein we use a helium gas or a hydrogen gas to make daughter ions of this, and finally we quantify this by using a Q3 source. So the thing is, this machine triple quad is majorly meant for the pesticide residual analysis or any of the quantitative analysis. Again, we have a patent in this. So we made the smallest collision cell which is available in the market. We can accumulate the ions and then we can inject it. Because of this, the sensitivity has been improved drastically. The standard sample we are guaranteeing a sensitivity of 50,000, which no one can match. Then this is about the top analyzer. Top stands for time of flight. So you basically give time to the ions to travel in a flight path. The lighter ions reach the detector first, then the heavier ions. So this is the reason in top analyzer we get the high resolution. This is an old technique, but still people are using that. This is a true high resolution mass spectrometer. We have installation in CPCB vector donor who are using for diaxial analysis. In this case, you can see we are using a quad lens, which is just seen, second quad lens, and a magnetic analyzer, quad 3 lens, then electric analyzer, and finally detector. This is the reason we are able to achieve very high resolution, which is required for the diaxial analysis to use. We are doing that. In case of mass spec, the other aspect is detector, which is finally detecting your ions. So there are 2 types of detectors we use. One is the electron multiplier, and second is the microchannel gate or NCP multiplier. Just to give you idea how this system looks like, this is a single quad MS. This part is GC, which is a gas chromatograph. This is a single quad MS, and there is a place to use those direct route. Which are talking about DIP, DEG. In bypass system, directly there is a hydrogen sample inside. This is a triple quad MS. It looks similar only, but the depth is more because we have Q1 and Q3 in this quad 1 and quad 3. This is the new spectrometer which I recently launched. This is T2000 GC. So this is the time of flight we are talking about. This is the path which is given to the ions to travel and finally get the resolution. Earlier version of this is recently installed in ship. This is the true HRMS we are talking about, the magnetic sector MS 800D. D stands for diaxial analysis. The similar sort of machines are installed in CPCB, Petaduma, Heating Nagpur. They are using this for diaxials. Then we have a very specialized source we call it DART. The full form is direct analysis in real time. So this is how the DART looks like. We have some other pictures also. So you can use this for any sample, for liquid, gas, for any sample. We can use this as a source and we can ionize the sample molecules in its native form. And last but not the least is the multi-top MS, which we were asking. I interview the techniques available, but we are not manufacturing that. Just for the information I'm sharing, that's available. But we are not into that market. We don't do that. So everyone in master, everyone has their own coating. We are not dealing in Andhra, but we are dealing with this technology and
So what is the organization rated from?
I'll show you. I have few images. I'll show you how it works. This is the multi-top MS which we recently installed in Shell. For GNDU S3000, this is a trademark product. Because in case of time of flight, the resolution formula says the path width, the more the path resolution is directly proportional to the pass length. So more the pass length, better the resolution. So in this case, though the instrument seems small only, so we have a patented optic design. When ions actually travel, the path length actually travels close to 70 meters. So this is the reason we are the only manufacturers who can achieve a resolution of 75. All competitors maximum they can achieve 30. So this is the reason that CCM will work. So I will give you just a glance about all the products and how you can analyze your sample. This is only shown the GC single quad analysis. So the mass range it can cover is 1 to 1000. Anything in between this, which sample which is volatile in nature, you can use to store. We have the highest capacity vacuum pump in its class. So this is the reason we can use this for the gas analysis. It is can be hooked with TGMS as well. As I already mentioned that we have large format hydrophilic part2. So the wide dynamic range is possible. We can directly inject water solution. We can get the spectrum of wide nodes. Only possible with you. Sorry.
Not volatile.
Yes, sir. So GCMS is the volatile. Then we have a dart and yes. Yes. So this one I was mentioning that there are two types of mass systems. One is the ionization section. So one is made for the volatile sensor. You deep the sensor is converted to gas and then you get via the other one is LCS. Wherein your sample is soluble, you get via LC and then you get by using the mass spectrum. The other one which you are having. GNDU already has an LC interface. Not from us, from computer, but from Google. Yeah. So I was talking about the large hydrophilic waterfall. We can directly inject water solution for wine. We have 12 filament design. No tools are required, as I already mentioned. We have a pre-filtered liquid waterfall clean so it work for a normal emission. Then we have a short rundown time due to high capacity vacuum pumps which have been well, GCMS we have recently announced. We just started promoting this product. There are a variety of sample pre-processing options are also available. Headspace is a very common technique which has been used since ages for GCMS. The sample is solid in nature. You put it in headspace. Then there is a methodology to follow. And by the fumes which comes out, we go via GCMS mass spec and finally get a spectral effect. We have a multi-shot pyrolyzer. It can be attached, but if people are interested in that, then again the same thing that a variety of non-GC sample inlets are available. DIPD is compatible with this. We can do the DGMS also. The key market area where people are using GC single quad analysis for environmental studies, for food safety, pesticides, for water quality, for organic synthesis in universities, chemical and many pharma companies are using GC single quad. For material engineering, synthetic polymer, people are using that by using the other attachment which are. The next model is TQ sensor triple quad 2000 GC. The main difference is you can see the mass range is same. This is the limitation of the quad, but the sensitivity has been improved drastically. In case of single quad, it is maybe covered 2000, right? In case of triple quad, is 1500. And very important aspect in case of triple quad is the ideal value, which is instrumentation detection limit. We can go up to 0.3 to control that because of the short collision cell which we have. The rest of things are same. You can use the same machine as a single quad MS also. Again, the same the market area is same, but the people who are interested in quantitative analysis, they go with the different quads. This is the model we are talking about that we have recently announced. The entire optics has been changed. It is meant for the complexion. Most of the petrochemical people they have the nature of the sample is very complex. They have different sort of hydrocarbons. So this is a very popular model for petrochemical people and people who are working in food and fragrances. This is how the system looks like. There are few key requirements if we want to talk about the GC top and this. First is the spectral speed should be very high. We are getting a 50 spectra per second. It is compatible with fast GC for high throughput analysis. It's compatible with GC also, which is meant for the petrochemical. ionization of 30,000 has been achieved after changing the optic design. Earlier it was 6,000, now it is 30,000. Again, you can, because of this, we are able to do highly selective quantitative analysis. Very high mass accuracy to 1 ppm we can achieve, which can be used for the identification of unknowns by the means of accurate mass measurement and elemental composition determination. We can do that. In this case, you can see in our terms, we generally say the USP, the unique selling point of this particular product. So it's the EIFI ionization score. So generally what people do, when they get this spectrum on the hard ionization EI, they get the very complex structure. Then they do the analysis of the soft ionization technique. Then they compare the data and manually they have to find it. In our case, we have EIFI ionization, the same component. So first you get the spectrum hard ionization, then soft ionization. We have a software MS5 analysis, which will do the results and finally do the structure information. So because of this was one of the key reasons that we are able to sell to the Shell. We were doing the R&D of these products. We had discussion with many petroleum companies. We had a solution in FPCL. BPCL discussion are going on. IUCL already. Depends on the products. So if we talk about multi-top, when we talk about multi-top, so let's say that we already have the best resolution numbers. There is a bit on the expensive side also. But still, if we compare with the top of the line model, we are competing. In case of GCFS and all, I'm not sure that they are that active. LCFS, we have a very small portfolio, which is what is a TART analysis that is showing us. So generally, we compete against NMR, the here we are quite good. So again, there are several pre-processing options available. Fiber, this is a very common thing which people use. Accurate mass measurement software FI can help to identify the unknown standards. Variety of nodes, several inlets are again compatible with this. This source we are showing earlier in FTE Pro, it is compatible with the top only, it's not compatible with the single product system because it is meant for the high level of interface. The key application areas of the market areas that people are using this for environmental, people are using for food safety, again for water quality testing, requiring high resolution for organic synthesis, and the main area where we are selling this product is the petrochemicals. People who are working on metabolites. This is the model we are talking about, which is dark, and this is basically LCMs, the one which this is how this is again a top analyzer which we are talking about, and the ion source is dark. So I was asking that how we are doing the analysis in 84. So with a glass rod for liquid samples, you can directly put the glass rod and you can get the data output from the top. The second is the ceramic sheet for the powder sample insoluble samples. You can directly use the visiting card. So this is checking that. Apart from this, if you use quizzes, you can directly get the tablet. You can get the spectra of the tablet also. Whereas once you go to GCM, so let's say this one, you have to change the form of the sample. You have to solve it and all. But in this case, the native form we can get. This is the reason it's a very popular technique for the forensic use. So recently in the US, forensic they bought 12 units of this.
Must be having some application notes also.
Yes,
You can share the participants.
we can do that.
Yeah. At least for now, and there are two diverse fields.
Yes.
So at least one or two papers for each.
We have an application notebooks on each of the product link. So I'll be sharing with you, you can share.
That will be very useful.
Absolutely. We can visit our website also. If the data is available on the website.
Yeah.
So if you have any questions, we have just a call or email. Yeah. So the key specifications and attachment options available in JLS given in LV. DART, which is direct analysis in real time, was originally designed for zero accurate of MS. It is available to be replaced by the standard ionization source, which is ESI, EPCI. ESI is electron spray ionization, which is for the LCMS. APCI is atmospheric pressure ionization. So we can easily replace that. The high resolution and exact mass measurement for selectivity will be the top analyzer along with this system for a high dynamic range, which is to analyze the mixtures The key application areas that people are using this is in drugs or medicinal illicit drugs, counterfeit drugs. This nowadays we are getting so many files for this also. So for explosives, yes, counterfeit drugs means when not in India at least, in US market there are many duplicate versions are available. So to analyze that, they are using this product. Whether it is, for example, they found that the site they found some heroin. So cross verify that. So they are using that. Then there are certain drugs are also available which is meant for the human use, but there are cases available. So you can cross check that. So you first get the spectrum of the right medicine, and the second, then you compare that, you get the news for that. For the explosive chemical basket agents, for instance, is said for metabolites it can be used in food and beverage. We have a specially ionization source for this. It can be used for that. For toxic industrial materials, it can be connected with the LC, the way you use the machine. With LCMS, it can be connected to TLC also. So this is the GNDU S3000. S stands for spiral top, which is a patented technology because of which we are achieving the high resolution. This is how the system looks like. This part is the spiral top ion optics, which can cover the mass range up to 30,000. As we were talking about it. We have a top analyzer to get this structure information. Then we have a linear top, which is an optional accessory for the high movement data box. As I mentioned, in case of spiral top, if you remember, in case of single quad, we can go to 1,000. In case of top, we can go to 10,000. In case of multi top, with spiral top, we can go to 30,000. 17-meter flight path, which is only available with your ultra high rolling power and high rolling power with the wide mass range has been achieved by this optics. Linear top is essentially used for the proteomics people where the mass range density can go to 500,000 times and it image the entire protein. That's possible with nothing. We have a top option for the structural analysis. We are able to do this high mass resolution power MS imaging because of the low flying path and accurate spatial distribution component contribution can also be obtained. So the key application areas where people are using this quantitative machine is proteomics, metabolomics, multi-imaging for polymers and lipidomics. We have the dedicated software packages for this. So once they get the data, they compare with the library and get information for all processes, so lipids, polymers, metabolomics, and metabolomics. Last but not the least, this is a dedicated model for diaxial analysis. D stands for diaxial moving. So as per European Union, we use HRMS technology only to cross verify the diaxials. There are certain limitations set. Discussions are going on. Maybe in the coming years, this will be a very technical. People will go with the GC system with the dedicated libraries. We are going in that direction also. So to do the diaxial analysis, there are a few key requirements. One is you should be able to set up the resolution at more than 10,000 very easily. There are certain parameters which have been fixed for diaxials. The resolution requires very high, the guaranteed resolution of 80,000, and the specific sensitivity. This is again our term for the USPs against the competition. So we have a socket type ion source for element and open that. We have a double column GC interface, automatic ball reservoir, automatic flag detector. We have a wide gap magnet analyzer. And the most important aspect in this case is this one. So we have a dedicated library we call it as diode, which is meant for the diaxial analysis. And we have recently announced a new version of this, which is compatible with GC triple Q also. As you mentioned, this is again the dedicated tool for the diaxial analysis. Thank you very much for your attention. We are able to open PDF file. So I'm going to show you how this identification works. So we can debug and elaborate a bit about the information. Thank you very much. I believe we have to go to the main.
Yeah.
So good afternoon to all. Okay, so let me introduce once again for myself. I'm a Deepak Kadam, as application specialist. I'm from Manitech Services Private Limited, and he is Sandeep. Sandeep Singh. He is area manager for sales in North Pan India. So actually, recently collaborated with the Geol. So we actually work in the proteomic instruments. Like we also collaborated with the JASCO, where we're selling the different chromatographic. Then your spectroscopic instruments. So mostly we generally deal with the CD, circular diaprisms, which we use for the secondary structure analysis. But the geols, we actually promoting the mass spectrometry since we have a lot of base in the pharmaceuticals and the chemical industries. Okay, to start with the geol. Geol actually has very good history about like we said, Rahul sir, he has very good history in the same time imaging technique. Even in mass spectrometry also they have a very large 16 years of experience. So the range of product what we are seeing actually provide the total solution which has been required for the various industries as well as academic and academic science applications. Along with the analytic, actually we have very strong base in all various good scientific institutions. We have delivered more than thousands instruments. Not rather than providing giving the solutions, we also provide good service solutions in terms of applications and the service supports. Okay. Okay. Next. Next. So this is the bus history about this. Okay, so these are already Rahul sir has been mentioned about all the product which has been in the portfolio of the geols, from the single cord GCMS, then triple cords, then top MS. So there are different mass analyzer which cater the need of different kind of analysis. Next. Okay. So the solutions for today's analytical challenges, like the geol mass spectrometry has truly provided total solutions for the requirement of the academic as well as the research institutes. So this, if you can see the mass spectrometry, modern mass spectrometry actually which is used for variety of applications in various kind of very different kind of fields. It provides your quality analysis as well as the quantitative analysis. So these two things are very much important when you go for your analysis part, when you go for any chromatography in GCMS or any LCMS. So these things will be very much important. Either you want to do a targeted analysis or either you want to do a non-targeted analysis. So these depend on the quality and quantitative analysis. So for the quantity analysis, we generally mostly in quantity analysis generally we require you generally take EI spectra, because in generally to go for the GCMS analysis, the ion source mainly EI, CI, FI. So there are two types of ion source. One is soft ionization techniques and another one is hard ionization techniques. Okay. So first of all, you need to understand where this GCMS or LCMS plays into the laboratory and what kind of application you can do with it. So normally you must having the different liquid chromatography systems. They have the different detectors, right? But the mass spectrometry is also one of kind of detector. It's generally count the ions which has been generated from the ion sources. So the ion sources, whatever ion sources are going to be used, that has to be or to play a very much important role. So apart from quantitative analysis, it also play a very much crucial role in various types of applications, like in chemicals, polymer. So find out the fingerprinting of the chemicals, then what polymers. So we know that polymers are the short chains of different small monomers, right? So find out the fingerprinting, find out the different structure formulas of that particular raw material. That also things you can do with the GCMS, LCMS as well as GCMS. Then the different types of environmental analysis, like for example, pesticide analysis. Then the different kind of pollutants, like Rahul sir, they have correctly said that the dioxin, PCB, polychlorinated hydrocarbons. So these are the man-made component which we have developed and we have sent into the environment. So in order to find out those, we have a specific instrument for that. In pesticide analysis, you know that in every like to increase the crop yield and everything, like we develop a lot of pesticides. different compositions, and we apply it on your or crops and all. So there are specific limit has been designated for each and every pesticide. So that also things we can analyze with the help of the. So we will go one by one in the previous as we move ahead. Okay, so Geo has more than one way to answers with this all type of questions. Then again, that like as I said, we have the different single chord, triple chords, top. Okay, so all these instruments has specific applications and they provide specific informations, right? The single chord, you can go with this. Mostly you can just you can analyze. Here you cannot analyze the structural formulas of your any component what you want to analyze. When you go for the say double triple chord, okay, so when you go for triple chord, you break those particular molecules, make it into different fragments, and this each and every fragment has each and every they have some fingerprinting regions, like they have specific formulas. So like puzzles. When you break the every components and when you again combine them together, it gives a lot of many informations. Like that top, like so each and every instrument has a different resolutions. Okay, so what is resolutions? So resolution is like you resolve your spectra very well. Suppose there is one peak. So there are many peaks under in the one peak, right? Like one atom unit mass. Again, there are different peaks, point 1, point 2. There are number of peaks which are inside the peaks. So that is the how you when you zoom your camera, so you seeing the pictures very much clear. Okay, so it's like a zooming of your spectra. This is the way of resolution. Like in a single chord, triple chord, or your top, you get as it goes on higher, you get a good resolution power. Next. Okay, so we'll just brush up the ionizations, right? The like you said, there is what I will say that there is no one ionization techniques or methods can support all kind of applications. Okay, so as you heard, as I told you about, there are different ionizations. So these are the different. So you have to select the anionizations method best for your applications. Okay, so this table on the left side of shows ionization methods we can use with the geol. So is actually you can see the geol mass spectral support a variety of ionizations methods. So this depend on the type of molecules we have been working on. It depends based on molecular weight, or also depend on the polarity. Okay. So instruments play their own role, but rather than going directly on the instruments, you have to do your homework. Like you have to very much pro in your sample preparations. You have to know your samples very well. Whether it comes from whether it is size of molecular weight of your molecules, whether it could be the solubility of your molecules. So depend on that, you have to select a proper ionization techniques in order to use the NEGC or LCMS instruments. Okay. Okay. So many times what happen that when you work on any kind of samples, the sample will not be remain a single absolute. It's sometimes a complex of samples. So sometimes you will require the combination of techniques. You will require the EI or FI. Okay. So again, I will brush up with one thing that EI is a hard ionization technique. The energy what we use that 17 electron volt. So that much of energy actually be required to break those each and every molecule that particular compounds. Okay. So when you break those any compound, when you ionize your molecules, it break into different fragments. That much of energy. On the other hand, FI field ionizations or chemical ionizations, this we generally provide a 10 electron volt of energy. So in the case of the soft ionization technique, we get a clear fragments. The small, we will not get a lot of fragments. It will give us smaller fragments of their molecules. So this soft ionization technique, the samples which are having thermally labile or they are not thermally stable. So for that molecules, you can use this soft ionization technique. Again, if the field ionization and field resorption also, it's similar kind of the soft ionization techniques. Yeah. Yeah. Yeah, actually, yes, EI and FI, because it is Geol is the only one company had provided two ion source together. So we can analyze the data of two ion sources. Yeah, it only one, but it is switching of the EI to FI. It's smooth. It's very smooth. It's under vacuum, so you don't need to switch the by switching. You don't need any hassles. Okay. So these are specifically designed for this industry for the as per the requirement of the industries. Next. Okay, so these are the different ionization techniques, right? So as I said, the electron ionization is a hard ionization techniques. Actually, it's good for the when you go for the structural analysis. Okay, so you must heard about the when you go for the quantitative analysis, right? You get a different kind of databases. Like when you go for any GCMS, there are the various packages you get, like niche libraries and Wiley libraries. So those all these libraries are contain EI spectra. So there are more than 2,000 of spectra which has been there. So like if you want, if your compound is very much similar to that, it will you have to take spectra, you have to feed those into that databases, and you have to get quantity analysis. But there are many compounds into the environments. Like when you go there, they are not into the databases. So for that, you will there are for that particular molecules for that particular analysis and research, the geol will provide different ionization techniques. Okay, so there are soft ionization techniques like chemical ionizations, then photoionizations, and the field ionizations. So the chemical ionizations can be said it is effective component for the higher proton affinities. You can do in negative mode ions. Okay, and most importantly, photoionization you can go for this. You don't require it is under the ultraviolet region. So like that kind of energy you has been used you use to that particular compound. It is mostly we use for the aromatic molecules. So if you're working on the aromatic like aroma perfumery techniques, so this techniques will be very suitable for you. Then the field ionization technique, it is the softest ionization technique. You can here you can apply less than 1 electrovolt of energy. So it is generally we require you can use for the compound which has really thermally labile. Okay. Next. So apart from that, there are also the desorption electron ionizations, desorption chemical ionizations, and the field desorption ionizations. So there's a different technique also we can use with the help with the geol mass. We have this all the ion sources in our portfolio for the different applications. Next. Next. Okay, so apart from this gas, like you know that the GCB mostly used for the analysis of volatile compounds, but there are certain instruments like we have like the DART MS and MALDI where you can use. It is thermally labile. Those these are for specific molecules actually. Like those have very thermally labile compounds. What happened sometimes in perfume in flavor industries? In flavor industry, when you try to develop new flavors and new aroma, when you develop, yeah, they're highly volatile. So for that, they use this particular. Okay, so next, like the as I mentioned, mostly we cater into the proteomics industries as well, and so here we have the MALDI, metric assisted desorption ionization techniques. Basically, we use for the higher molecular weight of proteins. Like initially, we were the MALDI. We generally people use for the higher molecular weight of proteins, but the design what we have in the instrument what we have come up with and the design what we have. You can also go for the small molecules as well, small peptides as well. So this is just examples of the lipid distributions in the mouse prints of the small systems. This is imaging techniques. What you can do with this MALDI. Then the DART analysis in real time. As I said, it is you can use for the forensics. Like you don't need to change the form of your samples. Whatever samples you can analyze with this, it will give the fingerprinting region of that particular molecules. Like in nowadays in forensic, like there are different species has been going to disappear. So take a log of that also because there are many applications. They have different application note on that also. Not on that, but even the forensic also. There you don't need to change the form of your samples. Any forensic compound doing samples that you can do with this data analysis. Next. So I will just give a glimpses of the software. Like I said, you use softwares. You instruments for different applications. But the software also play a very much important role to get a sense of data, to give a sense of your data, right? So when you go for the different, when you go for any top analysis or when you go for multi analysis, so there are the different software packages we provided to give a better idea of the data. So this is one of the KMD plot, Kendrick mass detector plot. Here you can see. So this is just the, suppose example, if you're working on the particular polymers, like in we go for polymeric industries, so they develop a different kind of polymer, the different molecule, they have the different kind of sizes. Okay, and in different sizes and different solubility and different intensity. So you can separate those depend on the Kendrick masses. You can distribute based on the masses and the can plot. So you can aid the hydrocarbon chains of the end chain of this particular polymer. You can study it very well. Okay, next. Okay, so coming back to the different applications, like we will start with the chemicals and polymers and materials. So geol has more than one way of solution provide the solutions. Like in the geol offer the solution in the raw material analysis, right? In supplied selections, then acceptance inspections, what the kind of quality of raw material, the chemical natures of that. So raw material sometimes when you go in many different kind of raw materials, there is a chances of get dilution. Like one dilution there is diluted in the sometimes. So you can find the purity of your molecules in their application. Then in research and development, then go for prototype testings, then the foreign object and investigations, okay, product elimination. So these features you can use to get good ideas. This also you can use instrument. You can also use for the quality controls and most generally to find to other various compliances. So next. So this is one of the example of the raw material examinations. So you can see that this is GCMS analysis combined with the multiple classification analysis, which actually enable you to speedy identifications and the characteristic component. So if you can see the example, this is different vinyl acetic resins were analyzed. This is the different resins like vinyl acetate resins. They have been analyzed by the pyrolysis GCEI top MS. This is the plot of the PCA analysis of the data. So which is the data item, which you can see that the data PCA score of 6 vinyl acetates, even the resins, even they look like same, but they have the different structural formulas and they have been divided into the different molecular weight. So this has been studied that is conducted by the one of the acids pyrolyzers. So you pyrolyze this particular resins and you can get a structural understanding of this data. So this is combined with the multiple classification and this analysis, and actually give the speedy identifications of the characteristics components. In the second thing, the additives, again same we have using the pyrolysis as a accessories with the GCMS, which the rapidly analysis of additives in the materials. So we can know that today's wide variety of the additives has been developed for this, which has been used in various formulations and for food, pharmaceuticals, and various polymer industries. So since these functions are depending on the type and the amount of the additives in the polymeric materials, so it is actually critical to identify the additives during the material examinations and quality controls. So if you can see this particular images, so this is a 2D GCGC image which has been conducted on the MS. Okay. So in this example, if you can see that this is the resolution measurement of 4 different additives from the numerous pyrolytical background components. So it's give a very easy understanding of the different additives in one. So likewise, sometimes when you do for any complex samples, like not one GC, you require 2 GC. Such as we require 2 columns. So one column we use for the polar component, and the second column we use for the non-polar component. So whatever the component separated from the one columns is identified with initially, and further the same another class of material can be analyzed in the second column. So there are 2D GC. You can type this is a type of 2D GC. What you can say, and give basic information about the polar as well as non-polar compound. So it give a better idea about the understanding of the complex samples. No, 2D I can now you can do that. And yeah, now it is 2, but people are come up with more higher version also. Yeah, but generally yes. So we can get a proper separations first of all, basically the based on the molecule weight. Yes, you can also give this when you go for converted analysis, you can give that. Next. Okay, so then multi also you can use for the base material identifications for the synthetic polymeric materials. You can see that. So if you can say the physical, actually physical property of the any polymer materials actually change according to the structures of the oligomers, right? And also depend on the structures and again the end group of their particular terminal groups, basically. Like every resin, so whatever the polymer material we develop, they are not last very long period of time. So depend on the different environment condition, they have effect on that particular molecules. So the base material identification you can work on this particular things.
What about concentration?
Yeah, actually in multi we just mostly in multi we do the profiling of your molecules. Like here many times you won't go for the quantitative analysis, but you go for the profiling of your molecules. So because here you get a high resolution powers. So each and small molecules, when longer mass range also we can identify. Yeah, it's more with this design, like beyond what we have, like we have the 70-meter path length. Like this small molecule, so you can resolve very well, and this in the multi. Okay, so here you can see this is the pilot top, like as I mentioned, like this is generally what we can see, like in multi, it provides the path length of up to 2 meters or 4 meters. But here with this design, what we are able to achieve is that we provide the path length of 17 meters. So not for larger molecules, small molecules, we can can do profiling of small molecules as well. Next. Okay. Then coming to the environmental analysis, so there are two main challenges we are facing into the environmental issues. I can categorize like in one of the pesticides, and second one is the environmental pollutant like dioxin, then polycarbonated carbons. So these are the man-made pollutant we have been developed, and it is very much hazardous if you are consuming. And we can say the dioxin is pretty much soluble into the fatty samples. So and the limit is also is designated. So this kind of analysis. So we have dedicated instrument for that dioxin, and we have dedicated software to analyze this particular analysis. Okay, so this so now before now also we have the triple quad as well. Triple quad is JSM 4000 to analyze this PCB. So this is just high throughput PCB analysis data of the first sections. You can see the embedded ratios and all the different PCB and that dioxin analysis. Next. So in coming to the pesticide analysis, like I said, in yearly we develop a lot of different types of pesticide for variety of crops to grow better and give a good yields. But when you go for any analytical laboratories, in one sample there are more than 200 or 300 pesticide residues are there. Okay, and in daily basis they want to analyze. They have to analyze more than 200 300 samples. Okay, so first of all, per samples we get different more than 300 pesticide residues. So that if you want to analyze each and every residues, you have to for that you have to the system what we are going to be used. It has to be very sensitive in nature. It has to be very accuracy. Sensitive in nature, what I will say is that how much signal to noise ratio, like how much dynamic range of that system you have. So some pastures has a limitation value of below 1 ppb level or 1 ppm level, ppb or ppm levels. So if you go with when you plot standard curve, like from lower concentration to higher concentration. So this is what we can say the dynamic range of your particular systems. So it can quantitate low limit of analysis, low limit of residues, also low quantity also or higher quantity also. So dynamic range also very much important, and the instrumentation detection limits. Like this is what I will say. This 0.32 factogram, it is lowest ideal value what we have been provided into the industries. Like you can compare with the other vendors as well, but this is the value of OFN values. But here you can see the if you have the lower, if you have the smaller concentration also, that instrument has a capable of to detect those particular molecules. So this is just one of the dynamic range of 4 pesticide what I just mentioned over here.
Is it possible to directly get here inside the instrument?
Yes, there are 2 things you can analyze. Like I said, like when you this particular GCMS, like you have anytime you require the GC to separate each and every residues. Okay, and second thing you can use the direct probes, direct insertion or direct exposure probe. So we have this.
Suppose you want to measure the air sample.
Yeah.
So if you keep the instrument here and open.
Okay.
So will it take air inside?
No. It is fully vacuumized systems.
In some sort of pressure gradient.
No, it is fully vacuum. But this is injectors. They are different fragments. When you see this design of the instrument, it's different fragments. Yeah. 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 That's an answer. Next. So this is Rahul has already mentioned about what the design is. Like we have because of when we say this, we have to analyze the number of residues in the pesticide and number of samples. For that, you need a rugged system. So this is quadrupoles, short collision cells. This is the proprietary one, and has provide a speed like in conventional GC. If you are taking 45 minutes of done, to get your analysis done. But with this particular instrument, you will get this the same analysis can done within 15 minutes. So this is the speed what we provide with this particular instruments. So it's a better with even better sensitivity and good high throttleness. Next. So this is one of the example of the short time you can measure the 260 component of the pesticide residues in the chassis. So this is the chromatographs. You can see that particular proper specifications. Next. So this is the ideal limits, and this is the sensitivity what we have achieved with this particular instrument. Like 15,600 is far ahead from the what comparative which is morely for 30 to 40,000, but we have provided a similar noise ratio of 15,000. Lower concentration also you can analyze. Next. So this is just a glimpse of the X-Crank, the software we use to study this particular, get understand about the analysis. X-Crank, the software we use. Next. And this is just the report outputs. Next, you can see the different components of PSC and different spectra, as well as the dynamic range of each and every molecule, each and every residues. Next. Okay. So Next, we're coming to the natural products and the foods and herbals. So there, JASCA has two basic two instruments like there is which suited for this particular applications. One is JSM 4000 and the second one is JSM AccuTop Dart OG. Okay, so if you can see this 2D map again, the first picture you can see the 2D map which is created from the aroma oil total ionic chromatogram, the compound which can say the identify from each EI mass spectrum and their corresponding structures make to the 2D maps. Okay. So here, as I said, this is one of the example because the column set we use for the first column we use for the non-polar and the second we use for the polar columns. The compounds were related with the reference to the boiling points. So this is the boiling retention time is depend on the boiling point of each and every samples in the horizontal axis, and the y-axis we can see the polarity of that particular molecules. So if you can the first molecule, these are cyclic monoterpenes, and as it goes on the forward into the pulse increase the boiling points, you can see the different alcohol groups like 12 to 13 minutes. So these are the different so you can see type of study can study with the help of this particular GC. This is capability of the GC. You can do that. Next. Okay, so this is again one of the different example like this is HECID product ion mass spectrum of the phenol and the specific. This is mass spectral ionization, and this is imaging of the metabolites. So even when you go for the in a metabolic analysis, when you go, this is altogether different kind of field. You can say where you can see we can study the small metabolite as well. Because normally when you go for the any biotherapeutic industries, when you go for the upstreaming industries, so there are the different they develop different metabolites and they characterize the different metabolites in terms of for that. So for that to use to analyze and to characterize those particular, you require different characteristic, not only separation but also you can require the imaging technique as well. Okay, so because each and every metabolite they can be segregated depending on the masses and their charges. So this is one of the example. It's when you go for any analysis, small conversion you will require. Sorry. Okay, size is the imaging size. What you say?
The concentration of the particular metabolite. Let us say it is nanomolar.
Yeah.
Will it be possible to set?
Yeah, only 1 mg per ml sample will require to get analysis. 1 mg per ml sample. Yeah. Yeah. Depend on nano form is what exactly you want to study. If it, you want to start. Yeah. See. Yeah, when you develop any nanoparticles, you use when you synthesize any nanoparticles, you use different excipient, right? You use different polymeric materials to get coating of that particular materials. That composition you can study. That composition you can analyze. Even you can, if it is volatile in nature, you can obviously go with these triple coats, or if you just want to profile it, then you can go for the top MS. Like in nano size, then you can get on.
Maybe some which are in nano form. You want to segregate the
yeah. Yeah, generally when your nanoparticle gets synthesized, like you obviously you done in various in specific condition, like you apply the different raw material, like you apply specific polymers to get coated your molecules, right? Whether it could be proteins or whether it could be any carbohydrate molecules. So there come the structural formulas of those every specific molecule what you are going to be used, that you can characterize, that you can easily get understanding of these molecules, what kind of structure they will form. Yeah. 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 Next. So this is the proteins. Like you can study wide range of applications of proteins. You can use multi-top as well as for the higher order structures. You can also get a Dart MS for that. Okay, this is just BSS spectra, just data analysis. Next. Okay, this is again the LC multi analysis of fragmentations of your peptides, small peptide. Like I said, the design what we have been achieved with this GOs. So not only in higher order structure, but in small peptide also you can characterize. You get profiling of your small metabolite as well. Generally used in the proteomics. Okay, so this is the resolution. Like this is one thing. This is for that in one thing resolve this particular thing. Create number of things inside. So this is ionic fragmentation what you can achieve with this multi because of the bigger longer path length to flight. Okay, next. So again, this is this common can say this is the ionic. This is top MS. Like here you use when you ionize your molecules. There are two type of top MS, like single ion formation or when you fragment the ions. So here we use the top MS. So in one top you get separation of ions. We pick up particular embodied molecules, and again we separate. We resolve those particular molecules. So this is what we can 2x of separation of your molecules. So this is just the spectrum embodied of each and every molecules. Again, you can zoom into that particular ions. So it again give you the different ions within inside the ions. So that it give you better resolutions like this. Okay, next. Okay, so actually there are a lot of things you can. So when you go for the GCMS or XMS analysis, so there are a lot of things you sometimes will confuse you in terms of analyzing and what kind of analysis. But these are the different techniques we can use. Okay. Apart from that, like I said, that rather than separations, we can also use direct insertion probe. So here there are the two assays we give: the direct insertion probe and direct exposure probe. So here you can see the mostly we want to analyze samples. You don't want to separate. You don't want to use the GC. Direct on LC, direct on MS, you can take expose your samples. This is just titanium rod. Okay. Like if you're working on this particular aroma of your molecule, like you go the food or any kind of compound which gives the aroma after period of time. So when you apply particular ambient temperature or temperature, so there you can use the direct insertion probe. Like there are tubes, glass tubes. You can insert the samples and you can apply particular heat. And once you apply heat, they can whatever the aroma inside the molecule, they can take, they can get ionized. You can analyze. Again, there are the direct insertion probe as well as this is the different direct sampling analysis features what we can also provide. Which? Yeah, when you first of all, like here you don't need a sample to be volatile, right? Then normally if you can have solid samples also, if you can keep insides and we under particular temperature, once they get ionized, you can find out this solution. You can get ionized. Likewise in GCMS also, like people use headspace like as accessories, like spiralizers. So next. So these are the different assays people can use with the people. Just if your molecule is not totally volatile, but semi-volatile in natures, or so that kind of molecules can use with the for that can use a different kind of this kind of assays like the headspace order samplers. The headspace it's liquid. Like when once you apply the temperatures or any other conditions, so they get what are the gases they come into the heads of your vials, and from that you can analyze those particular volatile compounds. So you have to treat your samples before to get analysis, get into the volatile formation. So for that, you will require different thermal desorption, thermal extraction assays. Again, you can also use a different desorption pyrolyzers for that. So these are the different assays you can use if your sample is not volatile, but we can make them volatile with applying different techniques. Okay, next. Okay. Thank you. That's it, because we have a lot of, because each and every instrument has capable of doing so many functions, and we have the various application nodes with itself. Even if you can choose for any environmental analysis as well as even pesticides, we have different application nodes on different pesticides for different compounds. Right. So if you want, we can provide you on the online. Whether you can also go for the websites. If you have interested, you can go to the website. You can get whatever interested application node what we require. If you want to do that. Okay. Yeah. First one. It's a failure. Yeah. So this particular like when you work on this is like when you work on the polymeric materials, even the biopolymers or in this other polymers, resins and all. So they have the different mass, right? When you analyze, you get even small to hard. Depend on the monomer size what they have. Even sometimes we also you can differentiate on the N group of the particular molecule, because when you say the different, if you find out different protein molecules, they have the different functional group at the end of it, S and N region. What you are saying. It depend on that. Actually, you can get. So this is in the this what you can say this chaotic form. You can get size distribution by size and distribution by the nature, like the what do you can say? Solubility, like polarity. Yeah, it is mostly if you're working on profiling of your samples, like top MS, where you get the resolution power. So even small molecules you want to identify with good resolution. So that where we use this packages we provided. It is come up with the packages. Like when you get this particular top MS, we give with the packages. This is KMD and the KMR block. So if you're working on the small and larger type of polymeric materials, even small protein also. Yeah. Whatever the ionic spectra we get, ionization spectra we get, the data what we receive, the distribution of your data has been done with this particular instruments, with this particular software. So these give better idea of how your data look like, rather than forming on the X and Y axis. Okay. Thank you for. Pyrolysis is where you give the it is the function of temperature. You heat your samples, like in small molecules. When you get particular heat, particular temperatures, so they reveal the structures like that. They come into the volatile formations. Yeah, it is erosion. है ना
Acquisition comes along with the which is used to acquire data. It is whenever I say it is free of cost, there are few packages are available. We talk with the launch, you can add on that, then we purchase. The data output is from the DC top and from zero DC top. You cannot see the other data. Yes, we have the user sharing rights. Regarding that, Nano also will discuss only one technique cannot suffice in leads. You should have a complementary technique. So SEM is nowadays very
We are one of those.
Yes.
Your job.
So SEM is a very important technique for the nano SEM. You have that also. For mass spec anyway, as I said, there are some prerequisites. So as we discussed, suppose every volatile, then you can go with CMS, soluble, and you go with LCMS. Then depending upon the level you go to, you can use the quad depending on the mass list, or you go to the top and you can go to test on the mass list also. Then you can calculate.
So next 7 days are for you. So we expect that you interact as much as possible. Only then you will be able to learn. And one thing more, if you can sample with you by recording class, then you can also do. And whatsoever you have seen here, you have listened. The same thing I will show so much. So that will help you to understand whatsoever information has been provided in the presentation. So if you have some queries, you can discuss.
Yeah, I think they can have this since the lunchtime is also approaching, and the next session has to start at 2:30.
Yeah, 2:30. So for that, let me thank both the speakers. Please join me. So that was our program. The next time now.